Welcome back. Today we're going to continue talking about the exponential growth and decay word problems, except for they're going to be a little more challenging. There's going to be a little bit different piece of information we're looking for. Yay, the bell. All right, so here's our examples. First one says, the number of Oompa Loompas, and yes, I love Willy Wonka, has been decreasing for decades at a rate of 8% each year. They are falling off the face of the earth, poor little Oompa Loompas. If there are 250 Oompa Loompas now, how many were there 50 years ago? So what we're trying to kind of work back to is we're trying to work back and find an initial value. We have our ending value. We know how many there are now. So if you remember our formula, which was, again, our ending value A equals the principal, and then 1 plus or minus the rate, and then the t is years. So it's going to fill in what we know. We know our ending amount. We know how many Oompa Loompas there are now. Right now there's 250. We don't know is how many we started with 50 years ago. But we do know things like they are decreasing at a rate of 8%, so I'm going to do 1.08. And we do know the time, 50 years. So I'm going to do a little algebra here. All right, so the first thing I'll do is I'll take care of my parentheses. 1 minus 0.08 makes 0.92. And then, of course, I would always do exponents. And 0.92 to the 50th power. It's going to be a big decimal. So the question is, how many decimal places do you use? Well, the more you use, the closer your answer will be to correct. I'm going to go ahead and go with 4. It's more than normal. Normally I say use 2, so it's a little more than normal, but not ridiculous. Now, p times 0.154, and I want to find p, so I'll divide both sides by 0.0154. The 0.0154s cancel, and I'll be left with my p, my initial value. So 250 divided by 0.0154, give me a pretty large number, 16,233.7. But since this question is about Oompa Loompas, we can't have 0.7 of an Oompa Loompa. So that means I would estimate there to be about 16,234 Oompa Loompas 50 years ago. That would be a solid answer for a question like this. So again, the same formula, just we're having a different piece of missing information. We're not starting with the answer. We're starting with the answer and working back to the beginning. Let's try another one. When planning for retirement, Billy decided he needs to have $200,000 saved by age 60. If the average rate on his investment is 9%, how much would Billy have to invest at the start if he is currently 20 years old? So he wants to take some money. Maybe he, had a relative that passed away or something, and he's got some cash. He wants to save some of it, but doesn't want to save all of it. Just save some of it. He wants to end up with $200,000. So again, he's not going to make any more contributions. Just a one-time investment. I'm going to make 9%. So let's fill in what we know. We know how much he has at the end. The ending balance needs to be $200,000. We do not know how much he started with, but we do know he's going to be earning an average of about 9%, or 0.09. And we know that if he's 20 years old now and he wants to retire at age 60, we're talking about 40 years. That's how long he has for this investment to grow. So again, we want to find out if he just wants to put in one-time lump sum at the beginning and never touch it again, just leave it sit there, how much money would he have to start with to have $200,000 40 years later? So once again, it's like an algebra problem at this stage. We're going to do the things we know how to do. We also know how to do parentheses first, and 1 plus 0.09 makes 1.09. We also know how to do exponents. That can happen next. So we're looking at 1.09 to the 40th power. Looks like that would be 31.4094. And again, the more decimals you use, the more accurate your answer will be. Right. Now at this stage, just want to undo this multiply, so I'm going to divide both sides by 31.4094. So let's do that. Take that 200,000, divide by 31.4094. And I got my ending answer to be $6,367.52. So that means his initial, whoa, if I can spell, maybe I'll just say that the bell threw me off. His initial, it's terrible at spelling. Let's try this one more time. His initial investment was about $6,367.52. Again, think about that. You take $6,300 and stick it into an investment at age 20. It's not a ridiculous amount. Like I said, maybe, he had a relative pass away that gave him some money, or he hit the lottery, or got a part-time job, and that's all of his extra overtime hours he's been saving. Who knows what the reason is. But again, if you take about $6,000, put it in the bank, let it sit there for 40 years, then you're going to have $200,000. So again, if you want to save for retirement, the key is to save early. The more money you can save early, the more likely you are to be rich when you're older. And that's what we all want. We all want to just be financially stable. $200,000 in cash would make me feel pretty financially stable. So I hope you feel the same way, and you plan on doing some of this when you're older. Start investing at a young age. Don't wait till you're 50 to start saving for retirement. Save for retirement in your 20s, and then you won't have to worry about it. All right, let me know if you need any help. Good luck today.